Good day, ladies and gentlemen. Today we're going to be looking at Unit 4, Lesson 2, video number, not 1, not 2, not 3, and video number 4. What we're going to do is we're going to look at a rational function, and we're going to analyze that function. We're going to do everything that we've learned in Lesson 2. So here's a nice function. We're going to find the domain. We're going to find the range. I think we're going to postpone the range. We are going to find the domain. We're going to find the vertical asymptotes. We're going to see if that booger has any holes. We're going to look at the horizontal asymptotes. We're going to find the X and Y intercepts, by golly. And then we're going to graph that rascal. So let's have out it, shall we? Let's. So the first thing we always do for a rational is find the daggone domain. So here's the domain. The domain happens when the bottom is not equal to 0. And right off the get-gat, that sounds really good. Right off the get-go, here's the top. Let's write the top out there, Leroy. The top is this. If I want to know where the top is 0 at, the top is 0 at x equals 1 and at x equals -3. Those are the x values that are going to make the top 0, because we're going to need that, homie. And I want to know where the bottom is 0, and here's the bottom. The bottom is x plus 3, x minus 4. This is really a good hint here, Lee, is to find out where the top and bottom both are 0. And if you look, where's the bottom 0? The bottom 0 at x equals -3 and at x equals 4. And that's going to help us right away. We're going to see, hey, what's the domain? The domain happens when the bottom is not 0. So the domain is all real numbers except x cannot equal -3, nor can x equal 4. Okay. Next thing we're going to find the vertical asymptote of that rascal. I'll write it out, vertical asymptote. And when do vertical asymptotes happen? They happen when what? If you're going to need your notes, ladies and gentlemen, boys and girls, they happen when the bottom is 0. Well, let me do this. Let me not write it there because I want to clean it up. They happen when the bottom is 0 and the top is not. Well, where is the bottom 0 and the top is not? The bottom 0 at 4, -3. Well, the top is 0 at -3. So there's only one vertical asymptote here, homie. And that is at x equals 4. Why? Bottom 0. Top does not equal 0 at x equals 4. That's your reason. Bottom 0, bottom does equal 0. Top does not equal 0 at x equals 4. So there's going to be an explosion in this graph. There's going to be some big giant explosion going on here of this graph at x equals 4. Now I want to know, is there a hole? Well, holes happen, possible holes happen when the bottom is 0 and the top is 0. So, look, at x equals -3, homeschoolers, and I say that as jest, but not really. Okay, so the top and bottom both are 0 at -3. So all you know is this function reduces. So since the top is 0 and the bottom is 0, since the top equals 0 and the bottom is equal to 0, I have to look at this guy. And these both happen at x equals -3. I have to look at this guy. I have to look at the reduced version. This guy is always in my way. X minus 1, x plus 3. Over x plus 3, x minus 4. So what I have to do is look at the reduced version. And I'm going to call that, I'm going to subscript that, the reduced version of that. I will tell you, all of this, the wholes probably are the most difficult. So you're just going to have to practice. So what's the reduced version? Oh, well, these guys here, these guys cancel. So the reduced version, would you put a parentheses on that, Leroy? Thank you. Is this. That's the reduced version. They're not the same, so I can't call them the same. Here I have subscript f. And I think in my notes, I think I used c of x. I wish I'd have used c of x, but I started with f. It doesn't matter. Okay, so now, how do I find the whole? What I'm going to do is put this -3 in the reduced version. Now you're going to have to take careful notes, Leroy. What is that? That's going to be 2 times -4, which is -8. -3 minus 4 is -7. So that bad boy is 8/7. Let's check the arithmetic here. The x plus 3's cancel. I have x minus 1 over x minus 4. I believe that's what I have. X minus 1. Yep, I do. If I put -3 in, that's where it happens at -3. That's where the top and bottom both are 0. Yep. So I put -3 into this. -3 minus 1 is -4. 2 times -4 is -8. -3 minus 4 is -7. I think I'm right. So what does that tell me? That tells me there's a hole at this guy right here. Okay, what's next on the agenda? Next on the agenda, let's see. Let's go back up here. Keep in mind, you can always pause it and then just come right back into it. You can pause the video. Let's go back up here. What's on the agenda? Let's see here. I found the domain. I found the vertical asymptote. Let's find the horizontal asymptote, i.e. the end behavior. So let's find the end behavior. To find the end behavior, I'm going to look at the original function, which is this. And I'm going to see what happens when x goes to quadrillion. And what's going to happen when x goes to quadrillion, I get this. I get 2 over quadrillion squared, quadrillion times quadrillion, over quadrillion squared. The quadrillions cancel, that's 2. So I make this statement as x goes to, I don't say quadrillion, that's silly. As x goes to positive infinity, my function goes to 2. In like manner, I better find out what happens when x goes, let's use a different color, when x goes to negative quadrillion. Well, let me tell you something, boys. What is f of negative quadrillion? Negative times negative is positive. Negative times negative is positive. This as well is equal to 2. And so I say this, I make this statement. As x goes to negative infinity, f of x, my function, still goes to 2. The last thing we want to do, ladies and gentlemen, boys and girls, is find the x and y intercept. So we need to find the x, y intercepts. The x-intercepts happen when the function is equal to 0. Okay, and if you look at your notes, x-intercepts happen when the top is 0 and the bottom is not. Top is equal to 0 and the bottom does not. There's so much, well, that's why there were 4 videos on this, Leo. So where's the top 0 and the bottom is not? Oh, how about at 1? Let me do this. Let me get this y-intercept out of here. It's going to be easy. So how about at x equals 1, the top is 0 and the bottom is not. Top is 0 and the bottom is not. So 1 comma 0 is the only x-intercept. Only x-intercept. There's only one x-intercept, and this is the only one. That's going to be very important when I go to sketch the graph. Alrighty. Next thing is find the y-intercept. Easy peasy. Find f of 0. If I put 0 in, what do you get? If I look up here at my function, if I put 0 in, I'm going to get 2 times negative 1 times 3 over 3 times negative 4. Negative times negative divided by negative is positive. So this is going to be 2 times 3 is 6. 3 times 4 is 12. Oh, 1/2. The y-intercept is 0, 1/2. I think I have enough information to graph this. And I will tell you this. We are entering the game, a part of this class, where people who are not used to studying, they don't study that much, and then they kind of get behind. Ladies and gentlemen, this has got to be a time you're going to have to really review these videos and watch them very carefully. There's a lot of stuff going on here, but I trust that you can do this. Students have been doing this for years. Okay, so now, let's see what we have here. We have found everything. We have the horizontal asymptotes, we have vertical asymptotes, we have the x-intercepts, we have the y-intercepts. I'm going to go to a new page, and I'm going to copy this problem. Well, what I'm going to do is this. I'm going to clone the page. And I'm going to view it, entire page. And I'm going to delete most of this. And write down what we know. I didn't have to delete the domain. And we'll go back to the second page. This is the page that we're going to write everything on. Okay, what do we know? The domain, x does not equal 3, x equals 4. That's what the domain is. This guy had a vertical asymptote at x equals 4. It had a hole. What was that hole? That hole was at negative 3/87. Go back here, I'm looking at that hole. Like here's the hole back there. Next thing I found was the end behavior. The end behavior, the horizontal asymptote. Keep this in red, big dog. Horizontal asymptote, y equals 2. I only have one x-intercept. The x-intercept is 1, 0. And the y-intercept was 0, was it 1/2? Yes, it was. So now I'm going to zoom out, and I'm going to graph all of that knowing this information and see what we can do. Okay. Go to 200%. There you go. So I'm going to put a grid here. I'm going to sketch the first thing I do, like I always do, is sketch the vertical asymptote at 4. There's a horizontal asymptote. The end behavior looks like this. Y equals 2 on both sides. Y equals 2. There's only one y-intercept, and that's 1, 0. And there's an that's the x-intercept. The y-intercept is 0, 1/2. And look, this thing has no other x-intercepts. And what happens at the vertical asymptote, the graph explodes. So I'm going to come through here, and I'm just going to go through the y-intercept and the x-intercept. Y-intercept, x-intercept. The graph has to explode down because it can't explode back up because there are no other x-intercepts. There's only one. And I have an error in my graph because, oh, look, over here, there's a hole at -3/8/7. So that's a hole right there. And notice 8/7 is less than 2, so it works out great. And then what goes on over here? Well, the graph has to go to 2 because of the end behavior. And what has to happen? Can it explode down? An explosion, the graph has got to explode up or down. It has to explode up because there's no way this thing can cross the x-intercept again because there's only one x-intercept. So we can get most of this graph knowing the end behavior and knowing the x-intercept. And the end behavior is y equals 2. X-intercept, we have the y-intercept, we have a hole, bam. And that's the graph, ladies and gentlemen. That is the graph. And the only way we're going to go through a couple more of these during class. So the only way you're going to get good is that at this is just by doing them and practicing them. You're going to probably have to watch these notes a couple times. So there's your graph of this function. This is what we looked at. Okay, this was the work to get there. All of this. Alrighty. So I will catch you on the flip side.